Hey guys, this is A Taste of Science, and today we're talking about carbon dioxide.
Please, nerd, welcome your stay. You've got no brains in a zombie buffet. When you go out, you order your meat like filet, which is only one of their real. Which comics are better, Marvel or DC? Do you prefer gaming on console or PC?
Now, normally I define our term, but I think everyone knows what carbon dioxide is. For those who aren't sure about the chemical side of it, it's a carbon atom with two oxygen atoms, carbon dioxide. Most people are probably familiar with it as what we exhale when we breathe out. And actually, that's probably the first way that we're familiar with putting carbon dioxide into a liquid. When you're a little kid and you're sitting there with a glass or something at the table and just that's actually one of the three most common ways that carbon dioxide is added to a drink. Not necessarily through breathing, but by just purely forcing carbon dioxide into the liquid. Some of it does get caught inside there. If you wanted to carbonate a drink using just your own lungs, it would take forever. You'd probably get lightheaded. You probably wouldn't actually be able to finish it yourself, but a bunch of people working together could probably make it work. In fact, that's how, but doing it with a tank of carbon dioxide is actually how a lot of sodas are made today, with just a large tank pumped through the liquid. Um, the process by which we exhale carbon dioxide is actually called aerobic respiration. Aerobic coming from a number of Greek terms for air life. It's the way that life uses air. And we take in sugars, in particular glucose, C6H12O6, and combine it with oxygen, O2, and we create energy for ourselves. And then when we exhale a combination of CO2 and water. Um, this is a very simple chemical process. We do it all the time. Pretty much every animal does it in one way or another. It's essential to life. That's why we call it the life of air, basically, aerobic respiration. Um, Another organism that does a very similar process and is used a lot for putting carbon dioxide into beverages is the use of yeast. I actually made some soda here, that just homemade soda. It's actually not that hard to do, um, which uses yeast in order to produce the carbon dioxide necessary for it. When yeast is introduced into a liquid like this, it goes through a three-step process basically. The first step is aerobic respiration. It uses up any oxygen that's trapped in the liquid as well as any sugar that's there until it runs out of one or both, and does exactly that same chemical reaction. Glucose and oxygen gives you energy, carbon dioxide, and water. Then it undergoes cell division. It creates a lot more yeast. And then it goes through anaerobic respiration, which is non-life respiration. It goes through a lot of chemical processes there. In that case, it still takes in glucose, C6H12O6, but it doesn't need oxygen to do it. Um, but what it produces is it still makes carbon dioxide, however, it also produces ethyl alcohol, CH3CH2OH. Um, and this process is where we get a lot of our things like mead. It uses water and honey as the primary source of sugars. In beers, we get both the alcohol content and the carbon dioxide from hops and sugars and flavorings that go into it, as well as the water and yeast. And then in wines, we get both the water and the sugars actually from the grapes. In this particular case, I made an unusual version of soda. I made a gingerbread soda. There was one really big reason why I decided to make gingerbread soda of all the things I could make, and that was what I have it here is baker's yeast. I don't have a beverage yeast at my house. You don't use it very often. I might make soda once or twice a year, if that. And part of it's because you only make about a half a bottle at a time. You need some extra space because that carbon dioxide expands as it's formed. It needs some extra room to expand into. Um, so I mostly made the gingerbread because baker's yeast does have a flavor to it. You can taste it. It's what you smell when you smell baking um, fresh baking bread. And I figured if I'm going to use something that's going to have a bready flavor to it anyways, I just might as well make the intent for it to be bread flavored. This is pretty easy. You set it out for about 2 days at room temperature, which I did. That's the process. That's the process by which the carbon dioxide is made. I didn't realize it was going to make quite that much, but as you can see, there's a lot of carbon dioxide trapped in such a container when you make your gingerbread soda or whatever kind of soda it is that you've created. Um, the Oh goodness, I've lost my spot because I'm kind of amazed at how much that is. I think I must have put extra sugar in this time. Um, that was the other thing that was interesting. For this, I used brown sugar as well as molasses rather than a cane sugar or like a refined white sugar, which again makes a little bit of a different process. I may have gone a little overboard, um, but that's part of the experimentation process that comes in the kitchen is learning how to do something new, and seeing how it turns out, adjusting your recipe, and all that kind of fun stuff. Um, Regardless, after letting it sit for a couple days, you put it in the refrigerator. The reason for this is you want to try and keep it from getting to the part where it does anaerobic respiration and producing alcohol. That is, at least if you're making it as a soda rather than like a beer or one of those kinds of processes. So I'm going to go take this over to the sink and I'm going to let it finish decompressing, and I'm going to bring it right back and show you just not all of the carbon dioxide is being lost in this process of letting it decompress a little bit. So I will be right back. So a lot of it came out. There was a lot of foam. I definitely put too much sugar in it when I made it. I was trying to get the balance right for an actual recipe for gingerbread. Clearly in the future I need to do less of that. This is part of the learning process. This is how you determine if a recipe is good. Make 3 or 4 different batches, make it slightly different ways, and see how it affects the outcome. But it's finally starting to go down, so I'm going to go ahead and pour a little bit into the glass here. And you can see there's not as much, but you can see a little bit of foam appearing on top. It is clearly carbonated. And let me grab a top to put it back on here. But that is one of the ways to make a soda of sorts, is to use a yeast process. Now, the last thing I'm going to talk to you guys about as far as carbonating a drink is the use of dry ice. Now, I'm going to cut away for just a second so I can go grab everything and bring it up, but I also want to take a moment and talk about using dry ice and being careful when using dry ice. So give me just a moment and I'll be right back with that for you guys, okay? Now, with dry ice, there's a few things that we need to go over for safety before we start talking about using it for carbonating a drink. The first thing is dry ice is very, very cold. It's not ice as in frozen water. It's frozen carbon dioxide. It's pure frozen carbon dioxide. At 1 atmosphere, which is sea level atmosphere of the planet Earth, it exists at about 110 degrees below zero in Fahrenheit. Very, very cold. Um, One of the things you need to be careful about with handling something this cold is you can get frostbite if you hold it too long. Use some leather work gloves from the garden, assuming you've cleaned them well. Use your oven mitts. They're insulated. It doesn't matter hot or cold. You can use them to protect your hands. Personally, I just prefer to use a dish towel. Again, as long as there's something between your skin and the dry ice. The other thing is packaging it in something thermally insulated, like styrofoam here. I also have a thermal insulated bag inside to further protect it. Because it is so low, pretty much anywhere you store it, including your freezer, is going to be warm enough that it can shift out of its solid form by a process we call sublimation. I'll talk about that in a little bit. But it's very important to keep it in something that's thermally insulated, like styrofoam, when you're holding on to it for more than a couple hours. So I can just open this right on up here and reach down inside, and I've got my bag in here, and inside this bag I've got just a big old piece of dry ice. You can actually see it starting to have stuff come off it just at room temperature. It's maybe 70 degrees in here, but you can see the trails of carbon dioxide coming off the bottom. Now, one of the other things that's very important, we're only going to be using a very small amount today. And the reason for that is that it expands a lot when it evaporates. Let me give you a little bit of an example of just how much it expands. If you have about 7 grams of dry ice, which is what we're going to be using today, about 7 grams of it, that's going to end up being about 4 liters of gas. That expands a bunch. You would never make soda in a plastic bottle like I did with the gingerbread soda using dry ice. Why? It's a 2-liter bottle. When this evaporates, even if it was in there by itself in a complete vacuum, if it was in there by itself and you let this evaporate, it would be twice as big as the bottle. Or more accurately, it would attempt to put an atmospheric pressure twice as strong as what's out here on the inside of the bottle, and it's going to rupture outwards. It can be really, really dangerous. Do not put dry ice inside a bottle or any kind of a closed environment unless you know what you're doing and you're taking extreme safety precautions. That's one of the great things about styrofoam. It's got lots of empty spaces. The lid does not hold on particularly tight. This one right now, my bag is actually preventing it from closing completely. There we go. But because it's got this this ability to open very easily, it's not going to worry about an explosion out in your garage or wherever it is that you're keeping your dry ice. Please be careful when you're working with anything like dry ice, anything that's not a normal household kitchen material. It has a lot of things that are very dangerous about it. There is one thing I did want to expel though, and that's the myth that you can't touch dry ice at all because it's going to hurt you immediately. That's not true. Only reason that I was using a dish rag earlier is I was trying to pull it out of there. In a second, I'll grab a knife and I'm going to cut some pieces off. I won't show that to you guys because I'm just cutting ice. And I will hold on to it with that then. But right now, just sitting here, yeah, I can pick it up and it just feels cold. It's cold. But I'm not picking it up for very long because if you hold it too long, like I said, you get frostbite. Please be careful. If you do this at home and you are a, quote, child, or I should say a squire, one of our 18 and under individuals, talk to your parents, make sure they're watching you, make sure they're helping you so that you're not going to get yourself hurt, okay? Please, 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 please. I'll be right back. I'm going to show you guys making a drink using dry ice. Just a second. So now I just want to show you guys actually putting them together. First of all, I have a glass here. You can see down in there is not a lot of dry ice. That dry ice is the 7 grams I talked to you guys about earlier. That entire thing is going to become 4 liters of gas. Now, why 4 liters of gas? As a lot of people may be familiar, there's the Pan-Galactic Gargle Blaster, probably the most famous nerd drink, and a lot of people have spent a lot of time trying to come up with an earthly recipe for all the ingredients, and I'm no different. I love kitchen chemistry, obviously, that's a big thing that brought me to doing this, but in particular, looking for a way to do a Pan-Galactic Gargle Blaster was part of the inspiration for doing this show. The big challenge I had was, how do you put 4 liters of gas through your drink? Obviously, you don't want to have to buy a huge tank of air every time you need to make one of these. So I finally came to the conclusion probably the best way to do it is with dry ice, because you can use, as I showed, a very small amount and still get your 4 liters. So let's go ahead and shake this up, and we will add it right on in. Now, I don't know how well you guys can see it. You can actually see bubbles coming up on top. That's the carbon dioxide coming out. I chose to have the drink start off chilled as an opportunity to make it take a little longer for it to dissolve. And of course, you can see the little wisps of carbon dioxide coming off of it. Those are actually a combination carbon dioxide and liquid, because they are, of course, the vapor as well as the gas. So anyways, this is sort of our summary for the drinks. I did want to show you guys one more thing, and that's that this is not going through a liquid state. It's a little hard to see with this example, but it's kind of hard to see in general. Most of the time when you're introduced to the 3 phases of matter, solid, liquids, and gas, you're taught it through water. And at 1 atmosphere, like I said, sea level atmosphere, as well as general room temperature, about 70 to 72 degrees. One of the big things is water actually goes through all those stages. It actually can transfer from a solid to a liquid to a gas, from ice to water vapor. However, as I mentioned earlier, dry ice does something that's called sublimating. Sublimating is almost like a combined melting, evaporating step, except that there is no liquid stage in the middle. At normal atmospheric pressure, carbon dioxide goes directly from a solid to a gas without even bypassing the middle step. That's actually why it's called dry ice, is because there is no liquid, there's no pool of water when it is melted. It completely dissipates. And so here we have it going directly from the solid state to the gaseous state. The wonderful thing is, with a drink like this, it's cooling the drink as it goes, because like I said earlier, it's at negative 110 Fahrenheit. It's cooling down the entire glass, the entire drink, which is one of the reasons I stuck both the drink mixture and the glass in my freezer first, is to lower their temperature enough. If you've ever seen glass go from really hot to really cold, it shatters. If you're going to try making something using carbon dioxide, I highly recommend that you cool down your container and any of your liquids beforehand. Even just a refrigerator will help. because then it's going to be less likely to break something. So I wanted to finish up real quick just to sign off the rest of this. You of course have your Hypermint extract floated over the back of a silver spoon, and your Zamphor. Alright guys, that is all for today's Taste of Science. I was really excited to do this episode. I hope you guys enjoyed it as well, and I look forward to seeing you guys in 2 more weeks. For now, have a great time. Go out and try something new, even if it turns out like my gingerbread soda and it's not what you were expecting. And please remember, the kitchen's a laboratory.